Hello everyone. Today we are going to present the project we had done on the Black Friday sales prediction. So first I will discuss about the problem statement. Our main idea is to identify the customer purchase behavior. For that we had build the model using the certain parameters and on various products. So for this to train the model we are using the data set. So this data set has a more than 5 lakhs rows and 12 columns. So here number of like fields, user ID, product ID, gender, which are useful to predict the customer amount. So coming to the libraries, coming to the implementation part. So we had done this project using the Python programming language. These are the core three libraries we used for development. NumPy we have used for manipulating the data. Panda is for data analysis and manipulation. Coming to Matplot library is for building the visualization. First, I will give little overview about the real example. Like, first, I will give about the real time example. Like for that, I have to start my application. Give me 1 minute. Oh, yeah, so I'm running my application. So it is running on the localhost 5000 port. So here you can see this is a visualization. If you give certain parameters like age, occupation code, and current years or product category, it will use a model and it will give the purchase amount. I'm entering some values. So here you can see this is the purchase amount based on the train model. So for coming to the next slide, my teammate Aditya will explain. Aditya, over to you.
Yeah, coming to the training and testing data. So the next slide. Regarding the DF total is the data frame where we append the train data with the test data frame. So the columns are as following. We have 12 columns. So we have 783,667 rows in this data frame. And coming to the next slide where we discuss about the data wrangling. So data wrangling is also called as data cleaning, remediation, or data munging. So it is refers to a variety of processing designed to transform raw data into more readily used format. So we can do this by two types: handling missing values and handling categorical variables. So missing values is we can handle through many ways by filling NA values, mean, median, mode, or some ways. And then handling categorical variables, there are three ways: using one-hot encoding, guided ordinal encoding, and label encoding. So coming to the next slide, where we discuss about the handling missing values. So the null values for product category 2, 3, and purchase are 245,982, 545,809, and 233,599 respectively. So we have used the value count function, which returns the unique values for product category 2. It has returned 91317 counts of 8. So we have considered mode for replacing any values in this product category too, because the data is skewed. So coming to the next slide where we discuss about the handling category variables. So we have categorical variables like gender, age, city category, state, current, city years. So we have used one hot encoding by applying get dummies function from pandas library on attributes like gender and city category. So the transformation for age attribute is done by ordinal guided encoding. So it is used when the variables in the data are ordinal, and it converts each label into an integer value, and then encoded data represents the sequence of labels. So coming to the next slide. The label encoding is the process of making labels machine readable by transforming them into a numeric form, basically. So it is a very, very important step in the supervised learning process for the structured data set. So it will be hard to process. It requires high computing resources and GPU to calculate the categorical names. So in this data set for the stain current city years column, some of them contains values such as 4 plus, which cannot be understood by the machine learning model. So we have used label encoding for the transformation of this column. Coming to the next slide, we have so the stay in current city years, user ID, and product ID are the discrete object features which we have converted into numericals using the label encoder in this project. So coming to exploratory data analysis, my friend Sujit will explain.
So in the exploratory data analysis, here first we have taken a bar plot uh, where we are doing the analysis for two variables, gender and purchase. So in the x-axis we have taken gender, and y-axis we are taking purchase. So yeah, here you can observe that the number of females have purchased much less than men during the Black Friday sales. Yeah, next slide. Here we have taken the count plot. We have two variables. We have one variable age where we have represented in x, and on the y-axis we are taking as count, that is the number of purchases. And here we can observe that the two category, which are people from ages 26 to 35, have purchased like much greater than any of the other age distributions. So we can see that it's close to 300,000. That is like 300,000 purchases in the Black Friday sales. Yeah, next slide, please. Yeah, here we have taken the cities, various cities, 0 to 4, that is like 5 cities, and purchases are made on these different cities, and we can observe that like 25, 250,000 purchases were made in city one. That is the highest number of purchases made like comparing with any other 4 cities. Next slide, please. Here we have taken occupation. We have like 21 different occupations and over 100,000 purchases. Like, and as we can see, like in the above graph regarding the occupation, we have the data set had masked the categories, and they have added the numbers for various occupations so that it is easy for us to make the prediction. So yeah, and the category 4 has the highest count among the population, followed by 0 and 7. Next slide, please. So here we have multivariate analysis, and from the data we have taken, you can see that. So this shows the correlation between different variables. So we can just see in the above graph that the two products, product category 2 and product category 3, have the highest correlation when compared to any other variables. As we can see, these two variables have a 0.46 value. So they are highly correlated with each other. Next slide. Data modeling. My friend Deva would be explaining. Deva, go ahead.
Yeah, the data modeling is basically applying the machine learning models on the data set, and we are trying to optimize the algorithm to find some patterns in the data set. Here we are using 5 supervised regression models on the data set, and the model performance is calculated by using any of the 3 methods given here. And next slide, please. And here we basically use root mean squared error as our performance metric for all the models, and it is basically the average distance between the predicted values from the model and from the actual values in the data set. The lower the root mean squared error, the better the given model will be able to fit the data set. And next slide, please. In the upcoming slides, we'll be looking at the regression models. The first one is the linear regression. It is the most common supervised regression model, wherein the model fits the best fit linear line between independent variables like age, gender, and the dependent variable like purchase. By applying linear regression, we got the root mean squared error of 4686. And the second regression model is decision tree. Basically, it is a tree wherein each node represents a feature and each branch represents a decision and each leaf represents a regression value. By applying the decision tree, we got the root mean squared error of 3440, which is significantly less than the linear regression model. And the third regression model is the gradient boosting regression model. It is basically the extension of decision tree, wherein the focus will be on improving the performance of each successive tree and thereby increasing the performance of the whole model. And by applying the gradient boosting regressor, we got RMSE of 3440, which is more or less same compared to decision tree. And the next is random forest, and it is the collection of numerous decision trees by randomly selecting the input data for each tree and then averaging the output for regression. By applying the random forest, we got the root mean squared error of 2985, uh, which is comparatively less than the decision tree model. And the last and final is the XGBoost regressor. It is one of the most powerful supervised regression algorithm, wherein each tree is made to learn from its predecessor about the residual errors and thereby optimizing the whole model. And by applying XGBoost, we are getting a root mean square error of 2834. And the next slide, please. And so among all the models, XGBoost has the lower root mean squared error, which indicates higher accuracy, and therefore we will confirm that XGBoost as the better fit among all the other models. Next slide, please. And in the future, we'll like to perform the hyperparametric tuning on XGBoost regressor using random search CV or grid search CV, and we would also like to perform more visualization on the dataset and handling outliers in the better way. And I hope you like the presentation, and thank you.